Hi guys, I welcome you here today also with this video now. I hope you guys are doing great. Everything else is going well. If you are watching this, I know you guys are completing 12 chapters of your class 9 mathematics. I hope you are not having any trouble in any of the chapters or having just revert back to those. If you are here now, that means you are ready to go with the next chapter now. You are on learning new, right? Learning new things every day. Keeping that attitude up, you guys, I'm back with this video. We are doing our mensuration part. So set up, I have this chapter here with you. It is your surface area and volumes. It is one of those chapters constitute maximum marks and is one of the easiest chapters, but it can be tricky as well at the same time. Remember this, it is easy. When I say this is easy, trust me guys, this is not that much tough. But again, if you are not applying particular logics here, if you are just doing any sum absent-mindedly, so you guys will be getting that wrong. This chapter will be, I will be covering this chapter into separate parts. Firstly, we will be covering up our surface areas, then we will be covering our volumes. What I will be going for is, I will be describing surface areas of figure. Then, while I've covered each and every figure and their surface areas, then I will be going on to volumes. I won't be keeping both of those surface areas and volumes simultaneously. I will be following your pattern of NCERT. I will be firstly just doing entire surface areas. Then I will be shifting towards what I can also do it in other way. I can do this. I can pick a particular shape. Let's say I pick a cube. What I do is I just tell you guys that I will be considering what I will be considering their surface area and volume, doing each and every sum related to your cubes and cuboids. Then shift to our another figure. Let's say cylinder. Here we will also do what surface area and volumes, then to next and then to next. I can do either of that or the previous method, but I prefer if you guys just do this, firstly learn surface areas of, then you move on to your volume. Volumes are easy, guys won't be having any trouble in those. The trickiest part is the surface area. I will be explaining it how the surface areas are considered, what are surface areas and what are volumes, and what is the difference between. Starting with this, I hope you guys are not bored. Starting with the video, again remember this is a mensuration part. You have to calculate each and everything. Please don't use calculators. I will be telling you certain shorthand tricks here where you can follow those and make your calculations easier. If you guys already know certain tricks, then do let me know also where I can improve. We are all here studying together. That does not mean I have to just keep and you guys just have to put everything down. If you have any, you can tell me. Without wasting your time any further, I'll start with my video now. So the video is surface area and volume the chapter. This is the video one of this chapter. I might not be able to complete this entire chapter in one video. It might be broken down into more than two videos or so. Starting with our first video, this is our first one. So the basics. Now I have my introduction here. See, anything around us can either be or 3D. That depends on the face that we are looking or the position that we are looking at from. Let's say I am just looking, you're looking at your screens, at your what you see is your screen which is having a lens, and at a given time if you're only able to see at one face of a given figure, that is what that is your, or you can say anything that you can see but you cannot exactly touch that. Let's say actually not the touch box. Let's say anything which you can see at either on the top side or the bottom side, but at any given position you get only its one face. Like if you guys are seeing, cannot see the backside of either your phone or laptops or your tablets, whatever you are on. You can only see its screen. Want to see its back, then you have to flip that. Again, if you are looking at back, you cannot see its front face. The face that you are currently looking, that is your 2D face. Now, 2D figures are generally what? They are generally on your papers. You can say you can look at look at them from any top view or bottom view or any side view. Any particular face that you can see at a given time, that must be a 2D. But let's say I consider this figure. Now, if you guys look at firstly this field, if you look at this field, if you're looking from side, then top layer green. At from the top, you can see is an entire space having greenery in that. If you look at this from top, what you see is a length and a width and the total area. That is what that here figures. So generally, it is categorized like this. Figures are actually drawn on paper, mostly drawn on paper, but you can see them in reality. But if you see this figure, the field, you see this field from your side view. Let's say if you see it from your this side, guys will be seeing the crops are standing in this field. Like crops are standing, so it has a height, it has a length, and any figure that has three dimensions, okay, three coordinates, that must be a 2D. Like if I have this field and I say I'm standing at this point, let's say I part this and I have only which axis? I have my x and y axis, two axes here. But if I consider this figure, this point, but your length, width, and height. Any figure which has three coordinates, that is your x coordinate, y coordinate, and z coordinate, if you plot this according to its three dimensions, that is what your 3D figures are generally those figures which you can hold in your hands also. If I tell you to just hold the field in your hand, can you hold it? Cannot because it's a field. But if I tell you to hold a pencil box in your hand, you can hold it. Anything that can be held in your hands, it is what your 3D figure. If you guys draw a rectangle on paper, cannot hold it. It is a 2D figure. But what if I tell you, pick that rectangle up, or you can say just pick your paper up, cut out that rectangle and draw similar six rectangles more and join them. You're getting a what cuboid, and you can hold that cuboid in your hand. Anything that can be held in hand is your three-dimensional. A three-dimensional figure has what? It has faces. It has many faces, and each face has a separate area. I know how is this might be confused, but let's say I tell you this. Let's say I consider my this portion. I know it has a top view. Similarly, its bottom part will also be congruent, so it must be having a bottom view. It has a side view also, right? And similarly, its back portion, that side will also be congruent. It will be having a side view, and this is its right view, left view. Now you see, at each and every viewpoint, you get a particular area. I will be having an area of this portion also. I will be having an area of this portion will also occupy area. Similarly, this will occupy, and that will, and the bottom one will also. So what happens here is a three-dimensional figure has many faces and it has area of each thing. So in order to calculate the area of any three figure, we call it simple surface areas. How we do it? Just calculate area of each, then we just add them and we end up having two types of area. One will be my total area and another one will be my lateral, or you can say curved. Curved can be happening when we have a curved figure, considering we have a cylinder, we have here, etc. And lateral surface area will be only those figures that have straight lines. Only the case of cube and cuboid, the curved surface area called, actually they will be having a lateral surface, and other figures will be having a curved surface area total. Terms exactly mean difference here. Lines will be straight in circle and lines, there will be no line, there will be. Starting with this, I have types of 3D figures. Firstly, I have cuboid. Cuboid is what? It is nothing but six rectangles. When you join six rectangles, particular order, the top side congruent to your bottom side, your left side congruent to your right side, the front side congruent to your back side. If you get six rectangles, two of opposite rectangles are congruent to each, that figure will be forming a cuboid. But I'm trying to tell you, if you take two rectangles which are congruent to each other, take another two which are congruent to each other but not to the ones, and you take another two which are not congruent to before ones. What you get here is you join those figures as per their opposite faces. That's what it means. This face must be congruent to the bottom face. Top must be congruent to bottom. Right here. Top must be congruent to bottom. Left must be congruent to right. And front must be congruent. Count this 1, 2, first and six. We have what? We have six faces. Face will have its sorry. Each face will have its own area. Just remember this. Your cuboid must be having these three conditions here. This. Know this. Your left face must not be congruent with your top face. Neither of the faces which are opposite to each other, no, or I can say this, no adjacent face can be adjacent. No pair of adjacent congruent. If they are congruent to each other, the figure formed will be what a cube has six. So in rectangle you have length and breadth. Right? That is the case of want to find out area of any rectangle. But in case of 3D figures, explaining later on, one dimension will be your length, in this dimension will be breadth, and this dimension it will be having three dimensions. If I give you give you a live example of cuboid, guys might must be sitting in a room, right? Guys always and guys have rooms, right? You have if you guys just look at any corner, either on the top or the bottom, any corner, look at your any corner, you will be seeing a vertex there. That is the point where the three lines are meeting. First one will be your line which is either going from the right or left. Another one will be like that one. Let's see what I'm trying to tell you. This is your figure. Yeah, I have it. Let's say this is the point. Now you guys see, this is your room and this is the point here. This X is present, this X is present. Your room is what it is, pretty figure. But you look at your any wall. If you look at any given wall, let's say you look at your wall which has a TV on it, LEDs are on it. You look at that wall. Now you can see only one face, but it is nothing but a 2D angle. Remember this, if you can only see one face of any figure, that is a 2D figure. Like it is a rectangle, you cannot just hold your wall in your hands. It's fixed there, right? But you can see for the case of room also, but you guys see end up having a box-like structure that is a 3D figure. You just look at any figure and it is a rectangle or whatever it has. If it has dimensions, that must be a 2D. Now, in case of remember this, your cube has six squares. That means face is equal to the other face. Every face will share the same area. I will be later on how its surface area is found out. Let's see. I have now cone. Cone is what? Cone is a that you can say it that what it truly. You just have a circle, tension it, and you extend it. Take the center, and you just keep stretching towards your other end. End up having a triangular shape at the top and a circular shape. What it exactly is, it's a circle attached to three different triangles. I will be explaining it to you later on how this is. Now you have your sphere, any 3D circle. Take your circle in 3D, you end up having a sphere, like your ball. Like ball is what? It is a 3D circle. Anything that you can hold, any circle that you can hold in your hands, it is what it is. And hemisphere is what? Hemisphere is the half of our Earth is also a spheroid. Like you can say moon is also sphere. Particularly anything which is round and is foldable and it is occupying certain area. That is what it is only drawn on paper. It is a 2D figure. It is physical. But when it is taken out from that, it is held in hand. It is like I might have said something. I will be explaining how cone. Let's just that one. Now, starting with the surface area. Surface area, I've already told you. The surface area is of all possible. If you can see any face, then its area must be counted in the total. I will be considering certain scenarios here. Let me get to that point first. For you now, total surface area is the surface area of all possible faces that can be viewed from any given side. Understood? Now I have this. I have curved surface area. Curved or lateral surface area. Now see what is this. This is the area excluding any given face, or you can say particularly lateral surface area is what is the surface area which does not have any top or bottom face. If you don't want to consider the top or any bottom face of any figure, any 3D figure, what you have is a lateral surface area. Remember this, lateral or curved surface areas do not have top or bottom. Let's say I have what? Uh, let's say I have a pipe which my water is supplied. Now you guys see it does not have any top or bottom. It is open at both ends. Its area will be counted which one? Its curved surface. But here is a catch. Pipe will be having certain thickness. On this kind of sums also, there is a catch here. We will be doing certain sums which are not in your NCRT, but are the important ones this chapter has to offer. For this chapter is quite lengthy. Is quite lengthy, very vast. It has various kind of questions that can be asked or that have been one of those chapters which you if understand right now, then you won't be having troubles in your class 10. But if you don't understand this now, you will be surely having many problems. Chapter surface area volume same as in your class 10. There is another chapter based on this, but it is a bit advanced. So remember this, if you guys not learn it here, be facing problems in 10. I remind you, understand each and everything. I will be explaining it to you how each formula is derived. So don't worry, you don't have to learn anything. You have to understand everything. Right? Let's see our volumes. Volumes is it is the total capacity. If I have a room, now see, you guys are sitting in your, you can fill your rooms with either clothes, furniture, air is already occupied in that. Any that can hold something in it, that must be volume. The maximum capacity of anything that can be held in a given 3D figure. Remember this, there is no volume for 2D figures. If somebody asks you find the volume of a rectangle, simply there is no volume for that because volume requires a height. It is what it is. This area multiplied by its the maximum area that it can occupy, maximum height it can go. You guys are putting, let's say I give you an example. Let's say you have a cylindrical, let's say you guys have seen that crayon box. It was a cylindrical box which had a plastic lid on it and it had cylindrical crayons in it. You guys remember, I've seen this. So if you just end up dropping your coins into that, the maximum coins that you can get is the maximum height it can go, and the maximum area each coin can gain is the maximum area of it. Please, guys, get my idea, or I can simply just tell you this. You guys drink water, you take your glass, your tumbler. If you pour your water into that, what you guys get? Get the water is risen to the height of the tumbler. Anything that goes beyond that height, it spills out. Right? So what happens here is the water is currently occupying certain area which is equal to the area of base, and it is occupying the total length of the tumbler. Cell height multiplied by base, that will be its volume. Volume is that. Now, starting with this, I have my first case. I have my now. For this, I have already written each and everything. I won't just writing everything. I will be rather explaining it to you. So, starting with this, I have my keyword. Words are what are when you arrange six rectangles in such a way that opposite faces have the same dimensions. If I take this, what I truly the thing that I told you earlier, If you take two triangles which are congruent, rectangles which are congruent to each other, let's say I put them at my top face and my bottom face. Right? They must share the same common dimensions. Let's say if its height is L, bottom face must be having an L as its length, but height is length. Now if top face has a breadth B, then the bottom face must be having a breadth, right? Now I do this. I just pick another pair of rectangles which shares the same common base. It has the same common length, which is but its height is h now. Right. Similarly, this will share the same common base b and a height h. Now this backside and front side, they both share the same common base l, a height h. What happens here is in every two opposite faces must share the same dimension. I take it here. Now you see, since we have to take rectangles, so let us assume their dimensions L being and h. Length being length, breadth being breadth, and height being h. What I do here, now you see here, I have how many vertices here? 1, 2, 3, 5, 6, 7, and 8. Now you have your 8 verses, right? Now, how many faces does it have? You guys see, it has 6 faces. I've already told you. Don't have to count them even. Now, the case of edges, or I can say sides. Edges are in what? Edges are in its cubes only. There are sides in the case of cuboids. Now, see how many sides are there. First side, third side, fourth side, fifth, sixth, seventh, eighth, ninth, 10th, and 12th. So you total have how many sides? You total have 12 sides. Although you have 6 faces, but two faces are actually 3 faces are sharing common sides. See, if you count this, this, and this, they are sharing this. Really, that is the case. You get how many sides? So you get end up having this here. The front face must be congruent to back face. Left face must be congruent to right one, and top face. This is the case here. Now, you guys look at this figure. You end up getting in every type of face. The top, this is the bottom. This is the front one here, this here. And the back one is the right face, it is blue. And this right must also. So, get an idea how this is made here. This is a 3D figure. I cannot just pick it out. I cannot just point it to you which face is of which color, but I can tell you this. If top face is saffron, then the bottom face must be saffron. That means it will be sharing its exact properties mentioned. If my right face is blue, then my left face will also be blue. That means it will be sharing in every dimension as it is given. Now, if my front face is yellow, that means my back face will be yellow. What it truly means is the color means that it will be sharing the same dimensions as my front face, and my right and left will be sharing the same dimensions, and my top and bottom dimensions. The case here. I hope you guys have understood the case of now. I have to find derive the cuboidal formula, its surface area. So now you guys know its side is 8 congruent to the opposite face. If they both have, if I calculate the area of this face as a length and it has width, its area will be what? Width, right? Considering I have just written front face here, so I consider this one length and this one breadth and this one height. But whatever you want, you can call them. If I consider this face, length into breadth, similarly your base area will be width. If you consider this face, you have a depth that will be height. Its area is what? Width. Its area, your left and one's areas will all width. Now come to your front and back. You have a length, you have height. That means area of yellow portion is what? LH, and the back one will also be LH. So you get what? LH, LH, LB, LB, and BH. You get this areas of 6 faces. Now you guys see here, front face LH, back face also, right face BH, left face BH, top face LB, and bottom face LB. You get this? Now you guys see here. Your front face is this length into breadth and length into height. The face now, right? This is your front face. It is sharing the length and height. So LH, back one also LH, left one, right one, BH, BH, and top one, bottom one, LB, LB. So you get this. You get twice of LH, so you can say 2 LH, right? You can say 2 BH and you can say 2 L. Taking 2 common, you have your total area, which is what? 2 into LB plus H plus. This is the total surface area of what? A cuboid. I have taken each and every face. That was the total surface area. Now, if the case of lateral surface area arises and somebody says to you to tell him or me the lateral surface area of that case. So, lateral surface area of cuboid is what? It is the area of four walls. You have to consider the four walls: front, left, right, and back. You have to consider these four. So you can simply say this: front face LH, back face LH. LH, right, left and right, 2BH, 2BH. So 2LH plus. Or simply you can do is take your total surface area, subtract the area of the faces that you do not. Now I knew in lateral surface area there is no surface area of top and bottom. Simply just subtracting from this to LB, I get what? I get this. You subtract this for you subtract this and this, you get PH plus 2 HL. Taking H common, I get this 2H into L plus. It is what? It is parameter of base multiplied by its height. Parameter of rectangle multiplied by height is your area of four. In mind, area of four walls or lateral surface area, it is the same thing. And just with relevance to this part, if there is mentioned to you that you are not taking certain kind of face, just remember this. You don't have to add its area. Just pick that face out, remove its area from the total surface area, or you can do this. What? See, I will be explaining it. If there is mentioned to you that you don't have to take an area of a particular face, then you can do that in two methods. First one, the first method will be this. Guys, do this. Take your total surface area and remove the area of that face that you do not. If there is any face here you do not require, what you can do is take a total surface area and subtract of that face. That is the case. Or you can do it first. Or you can do is pick your lateral surface area or your curved surface area. That means pick the area of only walls. Pick that up and add the area of that face that you want extra from that. Let's say if I did not want this top face, what I could do is I could just subtract the surface area and the area of top. Like I could do this, or I could do this. It's lateral surface area plus area. Is the lateral surface area is area of four walls. Either I can add the area of extra face that I want, my lateral surface area, or remove the area of that face that I do not want, my total. These are the two possible conditions by which you can calculate area of any figure which is given to you that there are certain faces which we are not. Like I will be considering certain extra portions in this chapter. Firstly, you have to understand each and everything. You have to understand basics. So this in cuboid, opposite faces share the same dimensions. So that is the case, and each opposite face is sharing the same dimension. So you will be ending up having these. Adding those, you got a total area which was. Now it was given to you that you had to calculate the lateral surface area, and you guys knew lateral surface area was what? It was area excluding top and bottom. So I had to subtract area of top and bottom from it. Area. Subtracting that, I got this, which parameter of rectangle multiplied by height, or you can say parameter of the base multiply its height. That is what? That is the actually I just cited the yeah, here this. We will be considering its four walls of this one together multiplied with its height. You get what? Get the area of walls. Now you see, guys have to find out the dimensions of a cuboid. Have to find out the diagonal of the cuboid. How you guys will be doing it is just square rooting You guys remember your what? You guys remember Pythagoras, right? It is a 3D figure since, so your diagonal square will be what? Square of L square, square each and every side and add them, that will give you the diagonal of void. Similarly, it will give you the diagonal of cube as well. Now, remember this, it is a 3D figure. I will give you the of this for this, but for now, remember this, the diagonal of cuboid is what? Diagonal of square root of L square, B square, and H square. Square of every side, adding them and square rooting them, that gives you what? That gives you the diagonal of a cuboid. I hope you guys have understood this. Now, coming to the concept of cube. Cube is what? Cube is any figure which shares six equal dimensions of squares. That means it has squares, six squares of each side. Its each and every face is congruent to each and every other face. It does not matter which face you are considering. In cube, each and every face shares the same dimension. Guys, see here. Now, if this is the case, so it does not matter which face you are considering, top, bottom, left, right, front, back, any face you pick up, it will be equal to any other face. See, if I pick this, my top face, it will equal to the back face. Also be back face. It will also equal to your left and right faces. It will also be bottom face. It does not matter which side you are picking, which face you are picking, it will be equal to any face. Like your cuboid, it also has six faces because we are taking how many squares? We are taking, it has six faces, it has eight vertices, and it has edges. It does not matter. Figures, the things will remain the same. Just the difference will be in the dimensions of both. Cuboid has every side different, has every side. Remember this? Cube has edges and that has sides. You can say vertices. Now, for this, you guys know its diagonal will be what? If you guys remember the formula of diagonal in the case, at this was L square H square. Since each and every side is equal, that means A square, A being your any side, so diagonal is what? It is B, right? This is the formula of diagonal a cuboid. If you guys remember this, I've already told you in the case of square, my previous videos, that square has a diagonal of square. See, this has it. Now let's see. Now let's see how its formula is derived. Since cube shares six squares of equal dimension and area of square is what? Is a square. That means its area will be what? Six faces, area of each a square. Its area is what? Unit. But this is an area. It will be only in square units. Centimeter square or meter square or even kilometer square, whatever you want, it will remain in square powers. Lateral surface area is what? It is that area of a given figure which does not share any top or bottom face. I have to consider area of four walls of a cube. In that case, what you have to do is subtract the area of top and bottom face. 6a square minus 2a square. What you get? You get a 4a square. Area of four walls in case of cube is 4a square. You can simply say lateral surface area of a cube. But it is understood. Again, this case arises if you guys have to add an area of a particular face. Let's say it is given to you that I have a cubical box. It is open from top. It does not have any top. You have to find its area. So you can do is what you can either subtract the area of top from your surface area, or you can do is what you can just take its lateral surface area and add the area bottom also, right? Because lateral surface area does not count any of its top or bottom faces. In that case, you will be adding the extra face that is remaining, or you can just subtract that face that you do not require from it. Cases will there be? First one, see, I can tell you this. Uh, if you guys have, let's just look at that. Remember this, you guys have to do this like this. Now, let's start with the next case. I have a plastic box 1.5 meter long, 1.25 meter wide, and 5 centimeter deep. It is open at the top, ignoring the thickness of plastic sheet. Determine area of sheet required for making the box and the cost of for it. The sheet measuring 1 meter square costs. Now it is given to you that I have a plastic box of dimensions 1.5 meter length, 1.25 meter breadth, and 65 centimeter depth. So that means it has three dimensions. A 3D figure. Now it is also given to you that it is a box, so you have to draw what? Its dimensions are different, so it okay. But our cuboid should be like this, right? If this is a cuboid and it is having a length of 1 meter and breadth of 1.25 meter and a height of 65 centimeters, what do I have to do? I have to find out the area of sheet required for making the box. It is not given to you that we are not considering any of the faces. That means what we have to do in those cases, we find out the surface area, then we have to find out the total cost, right? It is easy, right? So you guys know length is what? It is 0.5 meter. Width is what? It is 1.25 meter. And its height is what? It is 5 centimeter. Now see your cost is in meter square. So either you can do this, convert it into meter, or you can convert this one into meter, or these one into centimeter. So I'm going with centimeter. 1 meter square, 1 meter has 100 meters, so that means 100 centimeter. So that means 1.5 meter will be what? Centimeter, 125 centimeter, and finally centimeter. Right? So its area will be what? Total surface area is what? Tell me which formula should I apply? Surface area. Yeah, it will be this formula. 2 into LB gets L. That means 2 into 150 into 125 plus 65 into 125 plus 150, right? LB gets L. All this, whatever you get here, that will be area. Let's see. 125 and 1. Let me just quickly calculate this for you. 1875. Then 5 into 125, it will be what? 125. And then you have 150, a 9750. Add those 9750s plus 8125 and 1875. You get what? You get this 2 into 36625. That is, now you have to multiply it with 2. You get what? You get this 7350. Yep. So the area is what now? It is 73250 centimeters square. Now you guys see, it is given to me that the cost of 1 meter square is 20. That means cost of 1 meter square, this is 20. That means 1 meter square has what? 1 meter is equal to, write it for you. 1 meter equals to 100 centimeter. You have to square it. And this one also, you get what? 10,000 centimeter. 10,000 centimeter square is what? 20. 1 centimeter square is what? 1. 10,000. Now you have what? 73250 centimeter square. It will be 10,000 into 73. Whatever you get here, that will be your constant. Let me tell you again. It was given to you that there was a plastic box of dimensions. You had it. Sorry, we did wrong. Some. I got this. It is opened at the top. It is given to you that it is opened at the top. Let me just draw it again. I just did it here. Yeah, it wasn't having any top, so in that case, what I will be this. My TSA was what? It was 2 into LB plus BH plus HL. I wasn't required any top, so that means I have to subtract a BL from it. Now I know my values are these. Now you have to do what? Uh, let's just do it again. 2 into L is what? 1.5 into 1.5 plus 1.25 into 0.65. I'm just going for meter plus 0.65 into what? 1 point. That is the case. I have to subtract what? I have to subtract 1.5 into 1.5 here also. Solve this. Let's see what we get here. Get this 0.875 plus 0.81. You can do the calculations, right? Continue this, do the calculation on your own. Then you have to do what? You have been given cost of 1 meter square is 20. Just whatever you have here, multiply that term with what? See, your answer. Like, I will do the next one. Yeah, I will not be using calculator. The length, breadth, and height of a room are 5 meter, 4 meter, and 3 meter respectively. Find the cost of whitewashing the walls of the room and the ceiling. Remember this? We are whitewashing walls and the ceiling. Ceiling means the top one where we hang our fans. Guys, right? Know this? If this is the case, let me just draw my room here first. My room must be a cuboid. A cuboid. Now I have to paint this. I have to paint this, that, and I have to paint that one and this one. But I don't have to paint as. Let me just sit here. Yeah, I don't need to paint this one. This one is excluded. I don't need that one. That piece. I know this. What I can do here is, if my dimensions are, my length is 5 meter, my width is 4 meter, and my height is 3 meter, I don't have to paint that bottom face, so I can do this. Total surface area minus area of base, what is my required area, right? It was given to you that you are going to paint the four walls and the ceiling, but you are not going to paint as your floor. See, we are not painting our floors. It was given to us. It was obvious to us that we won't be painting at our floors. So in that case, I will be doing what? I can either subtract my area of base from total surface area, or I can do it like this. Area of four walls, or you can say LSA plus area of top. Either you can do it like this or you can do it like this. That is totally your choice. Using of four walls is fixed. I will be painting four of them, but I won't be doing is I won't be any base. Either I can subtract the area of base to my total surface area, or I can just add the area of top to my lateral surface. Any method that you want, you can apply that. I prefer this one to be. I don't have to do much calculation. I will be doing what? I will be adding the area of top to my lateral surface. Right? It is pretty. Now, for this, I know area of four walls or LSA squared is what? It is 2 into that means parameter of rectangle 2 into L plus B times height. Like length is 5, breadth is 4. Is always remember this, the longest side is your length, second longest is your breadth, and shortest one is the case 2 into 9. Okay, so that means 6 into 9. You get what? Get a 50 meter square, right? That is the area of four walls. I have to find the area of top 2. Area of top is what? Which that means 5 into 4, 20. So your total area be painted what? 4 plus 20. You get 4 meter square. So your total area to be painted is 74. Now, cost per meter square was cost of 1 meter square painting was 7.50. That means 74 meters square with 7.50 74. Bring this out, 37 and a 5 here, 3 here, into now whatever you get here, that will be your answer. Right? It was given to you that the room's dimensions were 5, 4, and 3 respectively, and it was also mentioned to you that the length was the length was 5, the breadth was 4, and the height was 3. Always remember this. If it is given to you, then you have to follow that sequence. If it is not given to you, just notice the longest side will be your length, the second longest will be your breadth, and the shortest one will be your height. Always take them in this order, unless or until it has been mentioned. Calculate them, whatever you get, that will be your answer. See, firstly, what we did, we found out the parameter of rectangle. It was 5 plus 4 multiplied by 3. That would have been 6 into 9. It was, and the area of top was 4 into 5. That was 20. Adding both of them, you got 74. Now, cost of 1 meter square was 7.5, and the cost of 74 meter square will be what? 7.5 into, solving that, I got this 50 into 37. Solve this, whatever you get, that will be your answer. I can write 37 to be this 40 minus 3, let's say 15 into 40 minus. Now guys, see, this will be what? It will give you a 600, right? Plus 15 plus 60 and a 0 minus 5. All this, you will be getting a 5 and a 5, a 5, 5. That will be your answer. I hope you guys have understood this. If there is any calculation error, do let me know, or you can just correct it on your and then let me know as well. Now, let's see our next sum. I have this sum now. The floor of a rectangular hall has a parameter of 250. If the cost of painting the four walls at a rate of 10 per meter square is 15,000, find the height of the. I have this figure. I have a rectangular hall. Let's say it is this. If it is this, and it is given to you that the area of the the parameter of the floor, that means the length of its edges, its boundary, but it is 2. That means 2 into L plus B, but it is 250 meter, and it is also given to you that the total cost of painting 4 walls, it is what? 4 walls at the rate of rupees 10 per meter square is what? It is 15,000. So that means uh 10 per meter square cost this. That means total area will be total cost divided by per meter square cost, right? So that means 1,000 divided by 10. So you get what? Right? Guess what? So the total area of 4 walls which was to be painted is 100 meter square. Sorry, it is 1500 meter square. Right. Now I know area of 4 walls is what? 2 into L plus B. That means parameter of a rectangle multiplied. Right. Right. I know parameter of rectangle is what? Now I can say this. Using everything else. Now I know 2 into L plus B was what? I knew 250 multiplied by H will be what? Of 4 walls, which was what? Which 100. Height will be what? 100 divided by, cancelling this. You get a 5, 3, 6. Get a meter. The height of wall was what? It was meter. Let me repeat it to you. The floor of a rectangular hall had a parameter of 2 meter. If the cost of painting the walls at a rate of 10 per meter square is 50,000, find the height of the hall. It was given to you that the 4 walls of that hall were to be painted. The 4 walls were to be painted. Had to paint only 4 walls. Now I knew its parameter. The parameter of the base was 250. I knew the area of 4 wall is parameter of rectangle, parameter of base multiplied by its height. I had to find its height. I knew its parameter was 2 into h will be what? It will be my total area. And I knew total area multiplied by 10 gave me a 15,000. That was the total cost of painting 4. If I had to find out its total area, what it actually was, what I will be doing is I will be dividing my total cost by per meter square cost. Dividing that, I got my area, which was 100 meter square. 50 into h is what? 100 meters. H will be what? 1500 divided by 250. Solve that, you will be getting a height, which is 6 meters. Right? Now, next case. The paint in a certain container is sufficient to paint an area equal to 9.75 meters. It is given to you that a paint in a container is sufficient to paint an area equal to 0.75 meters square. How many bricks of dimension 22.5 centimeter, 10 centimeter, and 7.5 centimeter can be painted out of this container? It is given to you that I have a paint container. It is sufficient to paint this much. I have to find the number of bricks that can be painted using that container. It is pretty simple. If it is equal to this much, if I divide my total capacity area that can be painted by area of one brick, can I get my number of bricks? If I want to apply tiles on a wall, what I do is I just find out the area of that wall and the area of one tile, divide both of them. I get my number of tiles that can be put on that wall. Right? This is the same case. I know the maximum that container can paint is an area equal to 9.375 meters square. What I will be doing is I will be just dividing both of the areas, your total area with the area of brick. And then I will be ending up with my number. Now you guys see, just this area here is in meter square and your bricks are in centimeter. Now you have two choices here. So you can just convert this into your centimeter square, or either you can convert into your. I chose going from bigger to small. 1 meter square, but it was 1000. It the case 9.375 meters square will be 9.375 into 10,000. I got this 93750. Right now I knew my one brick was void like this, and it's I am painting its each side, so that means I will be doing it finding out total of brick. Right, we have to find this out. I knew its length was 5 centimeter, width was 10 centimeter, and height was 7.5. Now let's go to its. I know total surface area is what it is. LB 0.5 into 10 plus BH, that means 10 into 7.5, and HL 7.5 into 5. All this 2 into 5 plus 5, and here you will be getting, let me 7.5. So you get this, get 168.7. Right? You add them, 225 plus 75 will give you 300. 300 plus 168.5. It will be what? And it will be 5 times. After solving this, each and everything here is 2 into 460.5 multiplying with 2, getting a 937.5 centimeters. But this, now you guys knew after converting, your total surface area was what? Total area we painted, it was what? It was just 93750, and area of one brick, it was what? This 9375. Number of bricks 93750. 935. Doing this decimal, you get a 10 here. Dividing them, you get a 100. The total bricks that can be painted are what? Bricks, right? Let me explain it to you real quick again. It was given to you that the paint in the certain container was sufficient to paint area equal to 9.375 meters square. It was as much as a 9.375 meters square, right? So its total area was that. It was in meter square and dimension of each brick was in centimeter square. Each brick was in centimeter. Either I could just convert my centimeter to meter, which would have caused shifting of more digits in my decimal. That would have complicated my calculation. Or I could do this. I could just convert my meter square into centimeter. 1 meter square was equal to 10,000 centimeter square. That would have been easier to calculate because we were adding zeros. We were multiplying with multiples of tens. Multiplying with multiples of tens is easy. Always remember, try to multiply in multiples of tens. That will quickly get you to your answer. So, converting your meter square into centimeter square, I got thus 93750. And finding out my total surface area of one brick, I got this 937.5 centimeter square. Dividing both of them, I got my number of bricks, which were 100. Maximum that can I paint using that container will be 100 bricks. I can paint 100 bricks using that container. I hope you guys have understood this sum. Now, let us start with the next sum now, which is this. A cubical box has each edge 10 centimeter and another cubical or cuboidal box has 12.5 cent. Actually, I have two figures here. One is a cubical box and another is a cuboidal box. Cubical box has an edge of this and a cuboidal box has these dimensions: length, breadth and height. I have to check which box has a greater lateral surface area and which has a smaller total surface. And in cases I have to check by how much. Which figure has the greater surface lateral surface area and by how much? I will be subtracting both the lateral surface areas for figuring out which has the bigger surface area and which has the smaller total surface area, and subtracting my bigger from smaller from bigger. Right? I had two figures. My first this and my another one. Let me just wait. Cube had an edge which was 10 centimeter. Middle figure had a length centimeter, width 10 centimeter, and height 8 centimeter. So firstly, my first LSA. Now I know it is for 10 centimeter. LSA is what? Into that, which is 100 centimeter. Now LSA of width, it is what? It's parameter of rectangle 2 L plus B, right? 2 into L is what? 5. Width is 10. Height is what? 8. All this into 2.5. 8. If you get here, you get 5, 8, 0, 32 plus 4, 36. You get this 360 centimeter square. Now your answer is clearly visible to you that the lateral surface area of cube than that of cuboid. And by how much? 400 minus 360, you get 40. So its area is more by 40 centimeters square. Now come to your total. If you had to find out which figure had a greater lateral surface area, that you had to firstly find out their lateral surface area of both figures, then compare them. Which one had the bigger one? You just have to subtract the other one from it, and the value that you got, that will be how much. guys know this how to do. I have to tell you why we subtract. Now, in the case of total surface area of cuboid, if I tell you the TSA of is, guys will already be speaking this. It is 6a square. It's easy. Just multiply your 10 its square with a 6. So you get what? 600. Its the surface area is what? It's 600. Right? Now I have to find out the total surface area of what? Void. This total surface area of is what? Guys will be just into LB H and into 12.5 into 10 plus 10 into 8 plus 5. Now you guys know this. This is get here 125. You get here an 80 and you get 0, 0 and a 10. So you get 100 here as well. Add them 125 plus 80. So 5 plus 100. So you get a 5 multiplying with 2. Get what? 10. Its total surface area is what? It is 610 centimeter square. While the total surface area of cube was what? It was 600. Which figure has the smaller total surface area? Is what? Cube. And by how much? By 10. See, lateral surface area of cube was more and it was more by 40 centimeter square. But in case of small total surface area, cube was the smallest and it had but it has 10 centimeter less 10 centimeter square less area than the middle one. Area of cuboid was more than that of cube. By how much? By 10 per much. Right? Now next case. Now have this a small indoor greenhouse, you can say herbarium, is made of entirely of glass panes. I have a greenhouse made in my indoors. It is made up of glass panes in the base. Its base is also of glass. It has six panes, glass panes. The faces. Its length was 30 centimeter. Its breadth was 25 centimeter, and its height was also 20. Everything was made of glass, so I have to find out its area. You guys know its area will be what? You guys tell me. I have to find out its area, so it will be what? Either LSA or TSA. I am counting each and every face because each and every face class. That means I will be this area, which is what? Into LB, H, HL. L being 30, B being 25, and H being 12 of them in centimeter units. Area will be what? 2 into 30 into 25, right? H 25 into 25 plus HL 25 into 30. All this 2 into will be getting a 750 here, right? You will be getting a 625 here. Here 750 plus 750. What? 600 plus 625. You get what? 1 5, right? Yeah. 0.25 multiplied by 2. Get what? 0, 5. You get this. Your total surface area of glass that is needed to build this herbarium is 4250 centimeters. See, let me just remind it to you again. This entire greenhouse figure was made up of glass. It was entirely made up of glass. That was the case. Then you had to do what? Had to uh, had to count each and every face. You had to find out area. That was the case. How you did it? You knew its total surface area will be what? It will be 2 into LB plus BH plus HL, right? Its each face was made up of glass. If its dimensions were 30 by 25 by 25, area of first face, that means my top face will be 30 into 25. My left face, let's say 25 into 25. My front face will be 25 into 30. So solve each and everything. You will be getting a 2125 into 2. All that you will be getting a total of 4250. right? Now, how much of tape is needed for all 12 edges? Now you have to check for all 12 edges, how much tape do you need? Now you see, one is what? It is 30, this 30, what? Have times 30, this is 25, this is 25. Have times 25 as well. This is 30, this is also 30, that means time more. Let me just divide this figure, then you can get this. Let's say this is the figure now. I have 12 edges. 1, 2. Now see, if this is length, then this is length, length, and this one will also length. That means I have 4L. If this is breadth, this is also breadth, this is breadth, and this one have 4 breadth. If this is height, this one is also height, and that one is, that means 4 height. Add both of them. Add each and everything, you will be getting a total length of tape. Now I knew my L was what? It was 30. So 4 into 30 is what? 120. 25 into 4 is what? 100. 24 is 5 into 4 is 100. So you get centimeter. I had to find out the tape that was needed to hold all 12 edges. It was just the parameter of the given figure. For this, either you could have just added your each and every side by side, or you could just know this. Each and every opposite face had a common vertex. I knew my length was 4 times, my breadth was 4 times again, my height was also 4 times. Solving those and adding them, I got this 320, which is the entire length of tape that I needed to build this. Actually, not to build this, hold each and every glass in its place. Right? Understood this? See, in second case, we had to find out its parameter. Now, next case, I have this now. It is one of the most important sums of your chapter. It is Shanti's sweet stall was placing an order for making cardboard boxes for packing their sweets. They were placing orders, they had to pack sweets in that. Now, two sizes of boxes were required. They required two sizes of boxes, the bigger dimension of this one and the smaller of this one. For all the overlaps, 5% of the total surface area is required extra. Now, you guys see, it was given to you that they had ordered two kind of boxes. First one of dimension 25 into 25 and another of dimension 5 into 50. They were doing what? They were having an extra 5% in order to overlap. That means to cover them up. If that was the case, they were having 5% of the in extra. What I will be having is, I will be having my total surface area adding to its 5%. If my total surface area is what? 100. So its 5% will be what? 5. My total value will be what? 5. What I'm going to do is, I'm going to find out my TSA. I'm going to 105%. Let me just tell you in terms. Guys are familiar with your percentages. You guys know you have to get an extra of 5%. Its original value was 100. So its extra value will be 105. So what I'm going to do is, I'm going to find my TSA. Either you can do it like this. You can find your TSA and add its 5% of TSA. It, or you can just simply do this. Just take your TSA, try it with 100. Totally your choice. You can do any of these. How we are going to do. I know my box one. Its dimensions are what? Length is 5 centimeter. I haven't read the entire question. If the cost of cardboard is 4 per 1000 centimeters, it says the cost of cardboard is 4 per 1000 centimeters square, and the boxes of each kind I require are 2. That means I have to calculate the total cost of 2 boxes of each type. That means in I will be getting a 500 boxes. If those are 500 boxes, and I have to calculate their total areas, then I have to find their cost. Firstly, let me just figure it out till here. I will be moving my cost part later on. You have to calculate as well. But calculate the area, then how can I calculate? First, focus on my area first. Now I knew for my first box, length was 25, breadth was 20 centimeter, and my height was the height It is what? It is the height, right? Height is what? It is. So the TSA is what? Have to close those boxes as well. I will be finding out its TSA is what? 2 into 25 into 20 plus 20 into 5 plus 5 into all this 2 into 500, right? This will give you 100 and this will give you 120. 500 plus 100, 600, 600 plus 125, 725 into 2 will give you what? It will 1450 centimeters square. Now, it was the original TSA. I had to add its 5% extra. Now, take out its 5%. 5% of TSA is 5 over 100 multiplied by 1. Solving this get what? Get 72.5 extra, right? An extra 72.5. So, your total area becomes, adding this 2.5 here and 12. So, you will be getting a 5 2, right? 1450 72.5. Get this 1522. That is the total surface area of box. 15.5. Now erase this. I don't need this. I will be telling you this question in three different methods. If you guys have a different method, I hope I will be covering your method as well. So firstly, the basic method in which I'm going to find out my TSA, then I'm going to find out its 5%, then I'm going to add it to that, and I will be my total area, which is for my case 1, my box of type 1 is 1522.5. Now box of type 2, box of type, if this is the case, now you guys see this. Uh, its dimensions are 15 into 12. The surface area will be what? 2 into 12 plus 12 into 5 plus 5 into. Now you guys know 10 into 2, 80, and this is 5. Add them. 180 plus 60, you get 240, 240 and 75, you get 315. Get what? 0, 6, get a 6 centimeter. The total surface area, 5% of TSA will be what? 620, 100, cancel out, get 1. Total surface area is what? 5, 651 centimeters, right? That is the total surface of one box of dimension 15 into 25. That was the total surface area of one box of dimension 12 into 25 into 25. Now I wrote this here as well. Type 2, it is 650 centimeters. Now I have been given each of type, each box of type 1 and 2. I have to take 3 boxes. Total surface area of 250 boxes of type 1. I will be having what? I knew, I knew what? I knew this. Area of one box. If I had to find out its area of one box of type 1, it was what? 152. Right? Is correct. Now see, this was this. So total boxes were 50. Total area. It will be what? 1, 2, sorry, 1, 5, 1, 5, 2, 5. All them, dividing it with 10. Them have this. Have 5 into 1, 5, 2. You get this. 3805, right? That is the total area of this one. Now its cost will be what? 4 over 1000 multiplied by 380. Right? Right? If the cost of let me just tell you. Firstly, it was given to you that the box order that was placed was for two different sizes of boxes. First one of 25, 20, and 5 centimeter sizes, and another one was 15 by 12 by 5. For covering them, I required 5% of extra. So for finding the total surface area of type 1, finding its 5%, adding both of them, I got my total surface area of one box of type 1. Similarly, finding the area of one box of type 2, I had to do what? I had to check what will be the cost for boxes boxes of type. Now I knew if the cost of one box will be 4 by 1000, firstly I have to find out the area of 250 boxes of type. Type 1 had this much area, 250 boxes. Multiplying them, I got this. Solving this, I will be getting what? I will be getting this. I got this. The total area is simply this. 1550 divided by 1000. 15225. That itself is the cost of all 250 boxes of type. Understood? That is the case for type 1. Let's say a type 2. Now for the case of type 2, I knew its area was what? 1. Area of one box of type 2. Calculate both of them. Area of one box of type 2 was what? Was 1 centimeter square. Total boxes were 250. Total area will be 1. Solve this. 250 into 1. You get this. 162500. Your total area. Cost will be what? Cost will be 4 over 1000 because 1000 centimeter square costed rupees. So cost of 1000 centimeter square was 4. So cost of 1 centimeter square will be by 1000. Total cost will be what? So by 1000 into 16250. Multiplying with 4, I got this 650 divided by 1000. So I got my cost which was 650. Right? Total cost was what? Total was 650 plus 1525. Add them 0.5 or 0.57 and 11. So your cost is what? 2172.50. I hope you guys have understood this. Let me just tell you once more and then we can move on with this. It was given to you that the sweet stall had placed orders for boxes of two different sizes. First one were of your 25 into 25 centimeter dimensions, and the second one were of your 15 into 12 into 5 dimensions. Each type of boxes, for each type of boxes, we had to have 5% extra of the total surface area of each box. I knew I also had placed an order of 250 boxes of each type, and cost of 1000 centimeter square cardboard was for. In order to calculate the total cost, firstly I had to find out the total surface area of box of type 1 and type 2, then multiply both of them with 250 each. Then after doing that, just 4 by 1000 of that, I get my cost. Right. Now there are two different methods around this. First one was quite lengthy and second one is easy. Just PSA of type 1 multiplied with 105 over. You will be getting a TSA of type 1. Similarly, TSA of type 2 105 per 100 because we are counting it's 5% extra. If you guys remember your SP formula, you know this CPA into 100 plus profit 100, right? Now, considering TSA is your CP and 5% is your profit because we are taking extra, TSA into 100 plus profit is 0.5 divided by 100. Like with this, now do this, add both of their areas and multiply it with 2. Why is that? Because you have to multiply this one with 250, you have to multiply with this one also with 250. Then you add both of them. Then you have to find their cost also. Let me just part this. Firstly, if you were going the traditional method, what you guys will be doing is finding out the total surface area, then finding out its 5%, then adding that total surface area, then multiplying it with your 250, then finding its cost. Truly, what we have to do is we have to find out our total surface area, use our profit and losses. I can say my 5% is profit here, or simply I can say 105 over 100 because the total value was 1. I had to take 5% extra. 1 plus 5 over 100. It is what? 100. So that's how I got this. Total surface area of type 1 multiplied by what? 5 over 100. Set the extra cost as well. Sorry, the extra area as well. Similarly, total surface area of type 2 multiplying with 105 over 100. Getting that extra as well. Now I knew this. I knew what? I knew this. I have to multiply it with 250. I have to multiply this with 250. Then I have to calculate the cost. Multiplying with 4,000. Multiplying this with 4 over 1,000. Then I have to add both these things. So rather doing each and everything like this, I have simply done it like this. How? Cost was 4 over 1,000 multiplied by what? Multiplied by 250 boxes of each type and their total areas. Yes, say type 1 plus yes, say type 2, multiplying them 105 over 100. Why is that? I have to take 105 over 100 of each and everything. It will be multiplied with both of them. I took it common. I had to multiply 250 with each of them, multiplying with this, multiplying with that, all common. Then I had to take its 5,000. I knew this. After I multiply 4 with 250, I will be getting 1,000. This is out. Finally, what I had this was PSA of 1 plus PSA type 2 and their 1. See, I think you guys are getting confused here. Let me just why I did this. It is as simple as that. Now see, you have you guys are sitting in front of me. Let's say you are sitting in my class here. If you are not watching this video, you are currently present at my room here. If I give you two toffees first, then I turn around and give you two more first. Then then I turn around and give you two. How many toffees did I give you? Six toffees. So if that was the case, I could have given you six toffees at my first attempt, right? If I knew, if I knew what? If I knew if I had to multiply each and everything, sorry, let me just tell you, I knew of type, I had to take its 5% extra. I knew its value will be 1 and I had to add its 5% extra. What I was doing, I was just 1 plus 5 over 100 of 1. So that means 1 plus 5 over 100. That means it will be 100. So I knew this. If my value was 1, I got this 105 over 100. If my value was my whole total surface area of type 1 boxes, so its 5% extra will be what? Surface area of type 1 multiplied 105 100. Now I knew this was the area of one box of type 1. You have two boxes 50 and I had to calculate the cost also. If the cost of one box was uh, cost of 1000 centimeters per cardboard was rupees, cost of well surface area of type 1 and 250 boxes of such type will be what? By 1000 multiplied by total surface area of 215 extra. Similarly, if I had my type 2, I found its TSA. Let's say TSA was this. I had to calculate its 5% extra. So this I had to find out the total surface area of 2. Well, then I had to calculate its cost as well. So that means ultimately what mattered was this. I did have to calculate this and this for the common parts for the both because we were just adding them. If both of these terms were in addition, can I take 5,000? Can I take this 2 common as well? 5,000 into. Can I take this also common? Because we are in multiplication as well. Multiplying with 5 over 100. What do I have here is just SA of type 1 plus all these two. These will cancel out themselves, then multiply 100. There is no obligation for you. Attempt like this. Whatever you want to do, however you want to do, just do it with that method, whatever you find easy. But if you are an intellectual, if you are keen on learning new things, I have told you, have to go with the traditional method, then go with this method. Because we have to ultimately multiply common terms with both the two types of surface areas. Rather than multiplying the calculation step by step, once again, just take everything common, add both of the surface areas, and just multiply for once only. That will be a bit easier for you. I hope you guys have understood this. I have spent nearly about 20 minutes on this particular sum. This particular sum. I hope you guys have understood this. If you haven't, just go with the traditional method. No, whatever you want, you can do it like this, or you're doing it like this. If I were the examiner, if I was checking your paper, I would be impressed. I will be amazed if you guys have done and guys have shown your intellectual. Always try to do different methods which are not taught in your books, which are not traditional, but they are valid. This method is valid, and this will be putting a nice word in your examiner's mind. Will be impressed. He will be knowing that this child knows something and he has to do and he has to exceed. Will be allowing you, focusing you even more than that, putting more efforts. Try to do anything with a different method, with a spark of you. Right? So now next case, I have this sum now. It is what Praveen wants to make a temporary shelter for her cat by making a box-like structure of tarpaulin that covers all four sides of the top of the queen wants to make a temporary shelter for her cat by making a box-like structure. It is a box-like structure. It's like this, like this. Uh, that covers all the four. Actually, not cat. It is a cat, which covers all four sides in the top of the. We don't require the base ones. Have this one. It does. Yes. Although its front face is rolled up, it can be rolled up and it can be rolled down. In mind this line here with the front face as a flap which can be rolled up and rolled down. It does not matter if its front face is rolling up and rolling down. Are using that face. Are using that face. So don't forget this. We are using that face. Assuming the stitching margin is very small and therefore negligible, how much tarpaulin would be required to make a shelter of height this much and base dimensions? So you guys know its length is what? 4 meter. Its breadth is what? 3 meter. And its height is what? 5 meter. Like this. Now you guys know. Guys tell me, what do I do here? What's what is the face here? Which face is here that I do not have to take? I don't have to take this face here because for it bar does not need any tarpaulin under it because it just needs cover over it. I need a top face. I need left face, a right face, a back face. But I don't need face. I can do it in two methods. My method is this one: the surface area minus area of. My second method, lateral surface area plus area. Top. I require my top. I do not require my base. From whole, I can take that thing out which I do not require, or from the part I have already have, I will be adding that part that I require. Either I can take the part out which I do not require, or either I can add my required part to the part that I have already added. In that case, I can method. I will be doing it with methods, and I will be how the answer is everything. I have this. My length is what? Meter. Width is what? And my height is what? It's PSA is into pH, then it's into L is what? Width is what? 3. Width is 3, height is 2.5. Height is 2.5 and length is right. L 5 plus 9 like 2 into 12 plus 10, 20 plus 7.5, it is 0.5. Get what? 0 and 19, 9, 10. But the total surface area, the base. Now it was given to you that if its total surface 9, it was given to you that I do not need the base. It's having four sides and top, not have a base. In that case, what will I do? Just subtract what? I will subtract base area from my area. That was the case. Then that was the then it's SA 9 SA minus I knew this 9 minus what? This area is 12. You get what? So the total area of the trampoline that probably required was 7 centimeter. Right. This was the method one. I could have done it with this method. If you were intellectual method, then you would have done it like this. That case, we'll be adding the area of top. The four walls method. Area of four walls or area of sorry of my lateral surface or lateral surface. It is what? Into L plus B. Height. L is what? L is 4. Breadth is 3. Height is what? 5 into 7. It is 5 centimeters. Right? That is the lateral surface. Right? Right? Now, next case. Now I have to add also area of top. It is what? Length into breadth, which is what? Into 3. It is square. Total surface area is what? 5. Well, it's still the same as the one have already done it. Good. Remember this? Whether you apply your LSA plus the area of required phase or TSA minus the area of the phase which is not required, you will still be getting that same area. I have understood this term. Now, next case. Yeah. So, with that sum, let me just remind it to you. It sums based on our cuboids. Starting with this case, I had this sum here, which was what? It was a plastic box. This dimension made one at the top, using the thickness of plastic sheet. Determine the area of the sheet required for making the box. The thickness concept I will be discussing with you when we have studied this entire chapter. Then when we have arrived to the point of cylinders that we have already did. I will be explaining the case of thickness in case of cylinders and in case of volumes. Specifically, thickness is either used in case of volumes or in case of cylinders. Anything related to a cylindrical figure or a curved figure, we will be considering its thickness in that case. While we can use thickness in this open cuboids also, but majorly they are used in a cylinder. So for that, in this case, you had to find out its area. You knew it was open at the top, so you do it in two ways. Either you can do it the way that we did our eighth sum in which we did this. We subtracted the area of the face which was not required. That means my top one from the surface area. That is exactly what we are doing here. Or we can do what? We can do this. Add the area of the required face area. You can do with either of those methods. You still getting this answer. Then we did this sum in which it was given to you that length, width, and height of the room for this. We had to find the cost of whitewashing the walls of the room and ceiling at the rate of 7.5 per meter square. It was given to you that we were painting both what? We were painting the walls and the ceiling. Had to take area of four walls and the area of desired face adding to that. In short, what we were doing, we were finding out the lateral surface area and adding the area of the face that we required, or we could have done it by this the surface area and subtract face that we did require. So both cases, you will still be getting that answer. Third question, at this, it was very simple. It was given to you that the rectangular hall had a parameter of this one. Its cost of painting at the rate of 10 per meter square was 15,000. Firstly, we found out our area, which was 15,000 divided by 10. It was 1,500 meters. Then we did what? We knew area of four walls multiplied by height was its the surface area, actually parameter of the base multiplied with its height gave you the lateral surface area. I knew if the parameter of the base was and its height was h, so its area will be what? 1500. I got my height, which was what? 100 divided by 250, height, which was 6 meters. Then we had this sum. I had a container which was filled with paint, and the paint could have been applied to an area equal to 9.375. I knew how many, I had to find out how many bricks I paint with that much paint. I knew if I find out the area of only one brick, then divide the total area with the area of one brick, I will be getting the number of bricks. Solving that, I got my answer. Now, in next case, I had this sum in which what we had this, had a cuboidal box, had an edge of 10 centimeter, another had these dimensions. I had to find out which had the greater lateral surface area and which had lesser surface area and by how much. Greater one was by cube, had the greater surface area, lateral surface by 40 centimeters. And the smaller one was by what? Void. Sorry, smaller one was again cube. 2. Cube had a larger lateral surface area but smaller total surface area and by how that you can solve this sum and figure that out. Now I had this sum in which it was given to me that the small indoor house germanium, I had a herbarium which was made of grass paste. It was given to me that it was made of entirely glass paints. It had six faces: top, bottom, left, right, front, back. I had to find out the area of entire glass. This out. Then I had to find out the length of tape that was required. Pulled all 12 edges together. I knew each and every side was repeated times. L for breadth for height give me length of tape. In my seventh sum, I explained it to you 20 minutes, so I don't have to use one again. And in this, it was given to me that Christine had made a temporary shelter for her car, which had a front going upwards. The front was detachable, it could up and up down, but it did not have any base. So I had to find out the length of trampoline that I required in that shelter. I used methods here again, adding the area of the that I required to my LSA, subtracting the area of the face that I did not require. Yes, solving both, I got my answer, which was we are going to begin today with our video. Now we are going to begin with this cylindrical portion. I'm going to let's start with this now. So cylindrical is